8.2, section areas and arc lengths. A sector of a circle is the region enclosed by two radii. So as we can see in all these diagrams, they've shaded in a sector, a sector of the circle, and we can see that the end of the sector is cut off by these two radii here. Right? They've shown in blue which sector they're talking about. Really, anytime you draw two radii in a circle, you're always going to end up with two sectors. For each circle, find the area of the shaded sector and the length of the arc that outlines that sector. All units are in centimeters. Give your answer in terms of pi. So just like we did for the do now, we're not going to multiply something by pi because we just get this irrational number. That's not totally accurate. When I want to be accurate, I don't want to round. Rounding is okay if we're, if being off by a fraction or a decimal is not that big a deal, but we don't really need to be that. We can write it in terms of pi. It's not important that we write it as a decimal. It's just the same thing. Same with radicals, right? Like if I write radical 5, right? If I write whatever it is, 2 point something, let me get my calculator out instead of being ridiculous. If I write radical 5, right, and I write that's equal to 2.24, that is less accurate than writing just radical 5. Same with pi. If I write pi, it's not really equal to 3.14, right? There's a lot more decimals, right? If I put pi in my calculator, you can see there's a lot more, and this will never end, right? It's irrational. So we always want to be as accurate as possible. And by keeping it in terms of pi, we attain that accuracy. All right, so for A, so first I'm going to find the area. All right, so we know that all the way around the circle is 360. They're telling us that out of that 360, we've gone 270. So I'm going to first write 270 over 360. All right, that's sort of the fraction of the circle. If you put this into your calculator, and some of you probably already see this, you're just going to get 0.75, or as a fraction, you're going to get 3 over 4. Can you guys see that? Is it bright enough? Yeah, you guys can see that. So I could just write 3/4, but I'm showing you where that 3/4 is coming from. All right, and then I'm just going to write my formula for the area of the circle if I was evaluating it normally. So pi r squared. All right, this is going to simplify to 3/4 times pi times 100. 3/4 of 100 is just 75, so we get 75 pi centimeters squared. Because we're talking about area, so that means my units are going to be squared. Now we're finding circumference. So let me break these up. All right. Yeah, let's do A all at once. Okay. So same deal here, right? I'm also, even though it's not talking about an area, I'm also using 270 degrees out of 360 degrees of circumference, right? That hasn't changed at all. We are finding circumference now, so I'm going to use my other formula, pi times 2r, or pi times 2 times 10. All right, a lot of you are probably able to do this in your head. That's okay. I'm going to write all the work. We get 20 times pi. 3/4 of 20 is 15. Or you could do 3/4 times 20 in your calculator, if that does not come easy in your head. All right, and circumference is a one-dimensional measurement, so it's just centimeters to the power of 1, or just centimeters. Doesn't get a squared. Okay. All right, B. Okay, so try and do this one, on your own, and then watch my work afterwards. That's what I would recommend. Okay, so I'm going to do it. Area equals 60 over 360 times 144 pi. And you see now that I'm starting to get the hang of this, I'm squaring 12 in my head. I know that's 144. 60 over 360 is equal to 1 over 6 times 144 times pi. 1/6 of 144 is 24. So 24 pi centimeters squared. All right, and hopefully you guys are using a calculator, unless you can do that in your head. I'm just going to explain what my method was there. I know that 12 goes into 144 12 times. So if I'm dividing by 6, it's going to be double the amount of times since 6 is half of 12. So it's going to go in 24 times as opposed to 12 times. All right, now for circumference. I'm not going to write that word again. Starting out with the same fraction, that doesn't change. 2 pi r, 2 times pi times 12, 1/6 times 24 pi. 1/6 of 24 is just 4, so 4 pi centimeters. Right, and you will notice, oh, this is interesting. 15 times 6 is 75. 4 times 6 is 24. Is 15 times 6 75? I don't know if that's true. That's not true. 15 times 6 is not. That was just a coincidence then. Yeah, it's times 5. Yeah, okay, good. I thought there was, I was going to say that coincidence shouldn't exist. Okay, yeah, ignore that. All right, next, this shaded area. So 135 over 360. Now that fraction I'm not going to be able to do in my head. I'll have to use my calculator. Although, let's see, this is 45, right? Yeah, I can't do that in my head. Maybe I can. Okay, never mind. I don't want to make a mistake. All right, 16 squared times pi. And really, you know, I'm doing this quickly. You always want to make sure that they label the radius, not the diameter. In a problem, they'll tell you which one it is, but that could be a common way they might try and trick a student on an exam. So 16 squared is 196 pi. I think this is going to be 3/8, but I'm not sure. Okay, so what I'm doing is I'm getting 135 divided by 360. Then I'm going to math frac to change it to a fraction. And I was right, 3/8. All right, now I've got that 3/8 there. I'm just going to press multiply. So 3/8 times 196 is going to give me 73.5, obviously, right? Pi. Great. And that's going to be centimeters squared. Okay. Circumference now. So actually, I already know my fraction is 3/8, so I'm just going to leave it like that. I'm not going to write it again. Just see how I'm trying to save myself a little bit of time every time I do this. 2 pi r. 2 times 16 times pi, 3 over 8, 2 times 16 is 32 pi, 32 divided by 8 is 4, so it's really 3 times 4 times pi, or just 12 pi. I'll double check that. I think I was right. Good. All right. Good, and that'll be in centimeters. All right, so that's all for 8.2. However, there is a really interesting problem. Are you ready for more? I will post the PDF of this online. This will be extra credit. And the reason I am not going over it is because I think it's actually, you know, one of the more attainable extra credit activities you could do here. I think that, you know, with the amount of resources you have on the internet, I think you could do a problem like this, and it's a very interesting problem. I had a guy come up to me in a deli one time. I guess he overheard me talking to someone. I said I was a math teacher, and they said, "Oh, you're a math teacher. Solve this riddle." And I got it super wrong, and it was pretty embarrassing. He's like, "Oh wow, you must not be a good math teacher." And I was like, "Okay, man, whatever you say." But yeah, it was very much like this, and it's sort of surprising some of the results you get. So give a look at that. Give that a shot, especially if you feel like this is not as challenging as the normal year. I would really recommend you go ahead and take a look at that. All right, that's all for 8.2.